Good morning to one and all. In the previous class, we discussed about different vibration techniques which are employed in a particular field to densify the particular strata to a particular depth, whatever the depth they required for a particular structure. That means depending upon the total structural weight and depth of the foundation regarding to the structure. That means to know today's topics we have to discuss about these compaction piles. That is one of the method which was used to densify the particular soil. That means piles means a type of construction. I will show with example of drawing. It is the ground level. It is the total foundation, particularly for a construction of a bridge. To bear those type of foundation, we need to have some kind of these piles. Okay, this is the total pile head. Pile head. This is the pile head. All those are the piles. All those are the piles. Okay. If you have a better understanding, whenever you studied in the GTE2 about these piles and pile driving techniques and different kinds of piles, so those are anchor piles, soil bearing piles, and friction piles, load bearing piles. We are having different kinds according to the structural usage itself. First of all, you need to know these compaction files, where we have to use these compaction files. What are the advantages by using these compaction files to the structure? All those things we need to know in today's class. First of all, this pile driving is one of the most effective methods for the compacting loose sand gravel. That means loose sand gravel. Already previously we discussed gravel soils, silty soils, clayey soils, and sandy soils. But in case of the structure which is having the sandy gravels, these compaction piles are used to densify the particular strata up to our required quantity and required level, so that these piles are normally driven by using a mechanical equipment having these bores and augers. Normally bores and augers for a small scale of structures are done by manpower. That means a man is simply pouring some amount of water on a particular place. He will use some augers, and he will some continuously rotating at a particular point, so that the auger will be penetrating into the earth surface and will have a huge amount of space, so that in that particular space you have to use these foundations and others for locating the particular earth levels and other constructional uses, so that these piles are driven into the particular soils to in a particular soils to remove the water quantity which is having on a soil, so that if the water quantity is less, automatically the soil bearing capacity will be high. In the second point we are having is that the method is also effective in silty soils above the groundwater table. That means above the groundwater table and below the groundwater table, we need to know these 2 points. What is groundwater table? That means in the soil itself we are having different layers, so that in the different layers we are having different mediums. I will draw with the help of diagrams. It is the entire earth itself, core, mantle, and crust. This is the above the crust, below the crust we are having different points. Okay, this is the crust, this is the core. At below the crust and mantle we are having this much of area, all this reddened portion. In this, definitely that portion we are having this water table. Why? Because if the water table is below the that point, automatically the water will be evaporated due to this heat which was formed on the particular earth surface, so that the water will be having at a particular height to the ground surface. Normally we are confusing two terms, that means confusing between two terms. What are the two terms? Means ground level and ground water level. These two terms are confusing to ours. Why? Because ground level means what is the surface we are walking, those surface is called as a ground level. What is the surface the water is flowing, those surface is called as a groundwater level. That is a major difference to the ground level and groundwater level. In the ground level itself we are simply moving, but in case of earth we are having different layers. At a particular layer, in a different areas we are having different flow patterns of water because of the availability of natural resources. Normally in the river coast areas we are having huge amount of this groundwater. Why? Because of there may be huge amount of penetrations, particularly in rainy seasons and other seasons we are having huge quantity of water lying on the above the surface of the ground level, so that all those water will be penetrated to the pores and they occupy the voids which are having on the below the ground level, so that all the voids are filled with this groundwater, so that the water will be flows below the earth level. All those are comes under this groundwater. Normally this groundwater will be obtained by digging a boreholes in a fields, agricultural fields. In agricultural fields some of them are not having these rivers like our Prakasam and other Anantapuram areas, and we are not having these river systems, so that they have to depend upon these groundwater boreholes, so that they have to dig up to 100 feet or 200 feet depth. They will have to form this water flowing on the particular location, so that they will have to use these PVC pipes and other hydraulic equipments like centrifugal pumps and other reciprocating pumps they have to use to catch the water to the fields. That is a major difference between the groundwater level and ground level. How we have to obtain those groundwater level by using different phenomena and principles. The groundwater table is very much nearer to the particular ground level. Automatically the soil is affected by the this water table. Automatically we need to have these compaction files to dewatering particular soil. It means dewatering means normally dewatering. We need to remove the total quantity of the water whichever is present on a particular soil to strengthen the particular soil properties and parameters like soil bearing capacity, liquidity index, plasticity index, and the swirling index, and next one shear capacity of the soils. All those we need to have to remove. Next one, compaction piles are therefore used in a fine grained soils that can vibration or vibro compaction. That means normally these compaction piles are mainly used in the fine grained soils, not in a coarse grained soil. Why? Because in the normally coarse grained soils we need to use these sand drains and other principles to remove the particular water. That means sand drains means we have to use these particularly columns like stone columns and other things to remove the particular water content in a coarser soils. But in case of these finer soils, that means the particle size is very less. We don't have to construct these sand columns and others. Why? Because of it is a costly procedure. We need to go for these compaction piles. The best effective utilized and obtained below the groundwater table where the soil is saturated. That means saturation means some amount of liquid limit is there. Those kind of soils are called saturated soils. Unsaturated means there is no proper water content to the soil. Those soils are called unsaturated soils. We need to know all those saturated soils and unsaturated soils. Soils which are having liquefaction or liquidity index, so those are called saturated soils. Soils which are not having this liquid limits, those are called unsaturated soils. That means saturation means the amount of moisture available on a particular field. Those are called saturations. Next thing is the compaction is partially caused by the vibration forms driving on the particular piles, and partially by displacement of soil caused by the piles. That means driving means normally by in the roads itself we are driving our vehicles. Likely to account these particular piles on a particular surface, we need to drive a huge amount of equipment which is perpendicular to the earth surface, so that we need to have these piles on a particular surface. By using these piles we need to dewater a particular land, and we need to remove the total water content whichever is present on the particular land. Next thing is the diameter of the compacted zone or ground each pile is 7d to 12d, where d is the diameter of the pile. That means 7 diameter or 12 diameter. Basically diameter means 1 to 2 feet we need to have 7d or 12d. That means if the total zone in the previously I discussed that we need to have some amount of these regulations, so that it is a 1d. All those things we need to maintain particular points. From that particular point we need to have some amount of piles, so that in each and every grid we are having each pile, so that by using that pile we need to dewater. Next thing we are having is the soil is also compacted below the piles down to the depth that corresponds to the about 1 pile diameter. That means the soil is to compact below the piles. That means compact below the piles. Whatever the pile we are driving on a particular soil surface, those pile has to be compacted below the pile. That means we are digging particular, it is the total ground level. We are digging up to particular this depth. Okay, below the particular zone, this is the below pile. If there is some spelling mistakes due to below pile, so that below the pile we need to go for compaction. Why? Because if you మనం అంతే వదిలేస్తే మనకి ఏమవుతుందంటే కాంపాక్షన్ చేయకుండా అంతే వదిలేస్తే ఆ యొక్క పోర్ స్పేసెస్ గుండా కూడా మళ్ళీ వాటర్ అనేది మనకి టాప్ లేయర్స్కి రీచ్ అయ్యి దా యొక్క పైల్ మొత్తాన్ని కూడా డిస్టర్బ్ చేసే ఛాన్స్ ఉంది. కాబట్టి వాట్ ఎవర్ ద డెప్త్ వీఆర్ టేకెన్ అనే పర్టికులర్ లొకేషన్, ఆఫ్టర్ ద డెప్త్ వీ నీడ్ టు గో ఫర్ దిస్ కాంపాక్షన్ టెక్నిక్స్ టు ఎన్కౌంటర్ ద entrainment of water onto the particular field. Okay, this is the main point. That means whatever the pile depth we are doing, after the pile depth is over, we need to compact the particular soil to arrest the water entrainment into the soils. Okay, next one we are having is the maximum economic depth is about 20 meters. That means while we going for the pile driving, the maximum economic depth means 20 meters. Economic means which is related to money matters. That means up to 20 meters we are having a free. After the 20 meters we are having a hard rock strata. That means to drive those hard rock strata we are having a huge amount of equipment and this money power. That means to drive in those amount of hard rock strata we have to use too much amount of power in terms of electricity or any other fuel we have to use, so that the total cost will be rises after 20 meters. Up to 20 meters we are having a economical value. After 20 meters we need to have some huge amount of economics to the particular soil strata, so that we need to remember all those things while we are driving a particular pile on the soils. Next thing we are having is it is usually possible to compact the soils to a relative density of 75 to 80%. That means the total soil which are having we need to densify up to 75% to 80%. That means a possible value up to 75% to 80% we have to do this compaction. It is not possible to do 100% compaction on a particular soil. Why? Because it is not a free space. We need to dig a huge amount of land. After the digging is over, we need to pour some amount of free particles. After the pouring of the particles, we need to use these vibrators and other compaction equipments to strengthen the soil, so that we have some amount of disadvantages. Due to those disadvantages, this 25% to 20% of soil having not purely compacted, only we are having a compaction factor up to 75 to 80%. Next thing is the method is economical for relative small areas compared with the other soil improvement method. That means this pile driving method, compaction pile driving method, is useful for a small quantity of areas, not related to a large quantity of areas. Why? Because in the large quantity of areas it is not possible to use these methods. The increase in relative density of the soil can be estimated in the form of total volume of inserted piles and the form of settlement of the ground surface observed during the installation. The increase of relative density of the soil. Relative density means particular soil having one kind of density before driving the piles. After the driving piles, we are having another kind of density due to this densification methods what we are allocated on a particular field. So that we need to have some relative density for that particular field. To increase this relative density, soil can be estimated to from total volume of the inserted piles. That means total volume. What is the total volume we are having on a particular field? What is the total volume of inserted piles? We need to have a ratio between the total volume and total volume of inserted piles, so that we are having a better compaction if we are having huge amount of this fraction. Next thing is the ground surface observed during the installation. That means whenever we are having these driving techniques, we need to observe the ground surfaces, whether it is any irregular intervals we are driving the piles. All those things we need to observe. Next point is building settlement can be eliminated as the structures were supported by a dense sand. That means building settlements can be estimated nearby the particular soil we are having any structures. Why? Because we are using a huge amount of vibratory methods and rock static methods, so that we are having some amount of vibration is flowing to the nearer field. If there is any nearer structures are located to the field, so that we need to have some amount of clarity on the particular building, so that how much amount of depth of foundation is there any effect to the structures. To control those effects, what are the measures we need to take care about the structure, so that those eliminate the building settlements nearer to the our construction site. Next thing is the reduction of the settlement by the compaction piles is generally large because of pile increases the horizontal pressures in the ground surfaces, thus the confinement. The reduction of settlement by the compaction piles is generally large. Reduction of settlement, that means increment and reduction. Reduction means automatically decrement of settlements takes place while we compact the piles by using these techniques. Generally large. Why? Because it piles increases the horizontal pressures in the ground and thus the confinement. Means while we are driving these kind of piles, there may be a reduction of the settlements and increment of confinement on the particular compaction files. That's he was mentioned here. And next one is the relative improvement is less when the initial relative density of the soil is high. That means if the soil having huge amount of density. What is the meaning of density? Means huge amount of particles are bounding on a particular location, so that there may be less improvement in the particular area. If the soil having less density, there may be high improvement. That is, those two things are inversely proportional to each other. If the density of the soil is high, the settlement will be low. Okay. If the settlement is high, where density of the soil is very low, those two things are inversely proportional. Next thing is the densification of methods in the particular cohesive soils. This is related to densification methods in cohesive soils. In the previous we discussed about densification methods in granular soils, so that the two types of soils are entirely different. We can the particle size. That means the total soils are classified into different kinds according to their particle sizes and chemicals present in the soils and others. In the previously we are discussed about different methods which are used to densify the soils in case of granular soils. But in case here we are having cohesive soils. In case of these cohesive soils, which methods are suitable? Different methods. So what are the different techniques to densify the particular soils? We need to observe what are the main methods used in these cohesive soils. The conditions improved when unsuitable soils are encountered. That means the methods are useful whenever there is a unsuitable soils are encountered. That means whenever we observe on a particular field, those kinds of soils are not suitable for the construction purpose. So that we need to employ some amount of extra features to the soil by adding or deleting amount of materials which are lying on the soil. In some cases, we need to use these densification methods, or it may be physical densification, or chemical densification, or mechanical densifications, whatever it may be. We need to have to employ onto the particular soils. If unsuitable soil conditions are encountered at a site, a proposed structure, one of the following four procedures may be adopted to the ensure safety performance of the structure. That means whenever we go to a particular site, that means the industry is allocated to a particular district. That means if we are having a huge amount of industries are coming in a particular areas, so that some of the company wants to construct a particular industry. That means it may be a steel industry or copper industry or bike factory or any other it may be. For a particular industry, they have to construct different structures on a particular area, so that in those area where they are having plenty of free soils. That means those soils are not suitable for cultivation purpose, so that we have to use those non-cultivated soils to industrial soils. In those soils also we are having some amount of disadvantages which are not suitable for the construction itself. If we are going to construct a particular structure in a paddy fields, it is not suitable. Why? Because those paddy is grow in all area or all soils, so that we have to choose a particular unsuitable soils which are not used for the agricultural purposes, so that we have to give importance. First one, by bypass of unsuitable soils by means a deep foundations extending a suitable bearing materials, redesign the structure and its foundations by supporting the poor soil. The first major things we need to have is we need to redesign the structural properties by increasing the depth of the particular structure. Means unsuitable soils may be huge amount of we need to have huge foundations, so that that huge foundation will have to support the structure in these unsuitable soils, or otherwise we need to redesign according to its foundation and poor soil conditions. Next thing we are having is this procedure is may not feasible or economical. That means this redesign is not suitable in some cases. In those conditions, what we have to do is we need to go for soil property changes. That is uneconomical or economical. We have to rethink and remove the poor material and either treat it to improve the replace or suitable for it with a suitable material. That means first of all we need to remove the poor quality of the material which is lying on the particular soil strata, and we need to replace that poor quality of material with a high standard material which is occurring available to the particular fields. Means in some of the cases we are not having a good quality of soil and good quantity of soil we are not having, so that we need to borrow from the other soil fields and we need to replace in a specified soil, so that we have a chance to improve the soil properties and treat the soil in place and improve the properties. And we have to place a particular soil which is borrowed from the another soil fields, and we need to densify the particular soil in that field. On the basis of this mechanism, we have to improve the engineering properties of the soil, but most commonly we have to divide into four major categories. Those are densification techniques. Densification techniques means simply by using these rollers and other rolling mechanisms to densify the soil by decreasing the voids contents. Next thing we are having is the reinforcement techniques. That means we have to include these reinforcement materials like steel, fiber and other things to improve the soil properties. Next thing is the stabilization techniques. That means stabilizations means we need to use some amount of admixtures to stabilize the soil like this fly ash, GGBS, stone dust and other industrial waste to stabilize the soil. And next one is the miscellaneous methods. That means different types of methods like boring techniques and other things. That means boring means pile driving techniques as previously we discussed. Like likely techniques we need to have to do on the particular soils. First thing we are having is densification techniques. All those densification are made by using these rollers. In the previous also we are having four types of rollers: flat foot rollers, pneumatic wheel tire rollers and vibratory rollers and sheep foot rollers. Likely those are the four types of rollers having different values depending upon the soil properties. And the reinforcing techniques also, in the reinforcing techniques normally we are using these fibers and other materials likely degradable fibers, non-degradable fibers and artificial fibers, carbon fibers, salt fibers, basalt fibers and steel fibers, crippled fibers. Likely in the fibers itself we are having a plenty of classifications depending upon their strength characteristics, so that we need to choose those strength characteristics and we need to apply on a particular field. Next one is the stabilization techniques. Means in the stabilization also we are having a plenty of varieties of waste materials which are coming from the industries, and those are called as a industrial byproducts like lime, a silica, GGBS, fly ash. Likely we are having different industries: copper industries, steel industries, aluminum industries and other synthetic industries. From all those industries we are having a huge amount of waste materials while they are processing a particular material. That means to obtain a particular amount of steel they have to use the basic raw materials like hematite, magnetite, and they have to obtain particular steel. In the process they have to obtain these waste materials as slag and others. All those things have to use in the particular stabilization techniques to obtain a proper soil properties. Next, miscellaneous methods. In those miscellaneous methods we have to employ some different kinds of physical methods and other drilling mechanisms to improve the particular soil. Apart of these, all the methods listed above are some other simple methods like removal and replacement of soil. That means removal and replacement means whatever the strata we are having with a loose and unconfined soils, all those soils we have to remove and we need to have to replace with another soils whatever the near we are having. Some of the techniques we are having is the preloading and vertical drains. That means in the term itself we are having preloading and vertical drains. That means whenever we are having a huge amount of water content on a particular soil, we need to utilize these two methods: preloading technique and vertical draining technique. That means vertical draining means we have to employ a huge amount of drains in the form of piles in a particular soil so that the water can be stored on those piles. We need to use these motors and have to remove the total soil which is present on the particular soils. That is a philosophy behind these vertical drains. Before that vertical drains we are having is the pre-loading techniques. That means pre-loading means we need to apply a huge amount of load onto the structure before going to construct a particular project. That means if we construct a particular project, the project is having such kind of weight. That means some amount of weight. The total project is having some amount of weight in terms of tons, so that we need to have that weight before going to construct on a particular site, so that what are the problems in future we have to face, all those things we have to observe by implementing these preloading techniques on a particular site, so that these two are very useful for the particular sites. First is a when highly compressible, that means the soils are very highly compressible. That means high compressible means manaki normally is when we take a sponge, it is a highly compressing material because of huge amount of voids are there in a sponge like materials. Likely in our soils also there are different kinds of soils which are having huge amount of voids. If the void content is more, the soils are more compressible or highly compressible. If the void content is very less, the soils is not compressible because of tightening of particles is there. That means bonding is there. Next one is normally consolidated clay soils are lie at a limited and a large depths. That means normally consolidated clay soils. Consolidation means application of these forces to the particular soil layers. They are lie at a limited or large depths. That means up to a few meters from the ground level. We need to locate these types of soils. Below the layers, we don't have this kind of soils because all those are clay soils, because the particle size is very much finer, so that there will be less quantity of the voids and huge amount of bonding is there in this case of clay soils and others. Next one is a large consolidation settlements are expected as a result loads from the large buildings. Whenever we construct a particular large structure, whenever we call it structure is a large structure, means the structure having huge amount of weight with respect to its body. That means if we go to if we take a apartment, it is simply a 5-story building. Whenever we go for a large building having a huge much of weight on a particular position, that means a 10-story building or 20-story building, because the 10-story building itself, the total weight will be focused on a particular part of a area. The remaining part of the area will be free without having any pressure, so that the total force exerted by the apartment or any body will be how to bear by a soil in a particular limit, so that there will be huge amount of settlement will occur on a particular portion, so that we need to have to employ these preloading techniques. Whatever the field we need to construct on a particular size of area, we need to apply this preloading technique. After applying the preloading technique, is there any settlement was occurring on a particular soil? We need to observe. After the observation is over, what are the values we are getting in future? If there is any rainy conditions or any other temperature disinfectant conditions, so what actions we need to take, all those things we need to observe by employing these preloading techniques on a particular soil. These preloading techniques are mainly useful for highway embankments. I am having another kind of PPT. After completing this first chapter, I will show those failures of different structures with respect to temperature and our locomotives. That means whatever the temperature in the particular locations and structural features we are having on a particular locations, those also having effects on the particular locality of an area in whatever the position we have to construct. Next one are earth dams, etc. Some types of cases, earth dams means the total earth dam means the dam is constructed by using the material which is available on the earth. We are not using here artificial binding materials like cement and lime. Normally we are using this clay or whatever the matter which is surroundingly available. So that means surroundings available matter తో మనం ఎర్త్ డ్యామ్స్ కన్స్ట్రక్ట్ చేస్తాం. Why? Because to store a huge amount of water for agricultural purposes, these earth dams are constructed in many places. All those are examples for these structures where we have to implement these preloading techniques and vertical drains. After that, we are having a small conclusion. This pre-compression and provision of vertical drains are in soft soils may be used to minimize the post-construction settlement. That means this pre-compression and provision of these vertical drains will arrest the post techniques, whatever the మనం ఒక స్ట్రక్చర్ని ఒక ప్లేస్లో కన్స్ట్రక్ట్ చేసాం. ఆ ప్లేస్లో మనకి ఏమవుతుందంటే ఆఫ్టర్ ఫ్యూ ఇయర్స్ వీ విల్ హ్యావ్ టు ఫేస్ దీస్ సెటిల్మెంట్స్ అండ్ అదర్ obstructions due to these soils, so that by previously we are adopting these preloading techniques and vertical drain on a particular soil, those things will arrest the future settlements on a particular soils. That is the main content. That means post construction settlement. Post means after the construction, pre means before the construction. If we apply a techniques before the construction, we will arrest the post construction settlement. That means after the construction there is a small quantity of settlement. Those settlement will be arrested by using these preloading techniques. This approach has a result in a number of techniques involving. That means what are the results we will have to obtain by implementing these methods on a particular soil strata. First one is the pre-compression or preloading. This is the one of the method we need to implement. Next one is the sand drains. That means sand drains means these sandy materials are filled in a particular columns, so that the sand will have a capacity of bulking by absorbing surrounding whatever the water having, so that the total amount of water will have to absorbed by these sand drains, so that the total amount of water will be drained. Next one is the prefabricated vertical drains. Vertical drain means in some of the places we have to use these vertical drains to drain off the water which is having in a particular rainy seasons. That means prefabricated vertical drains are used to drain off the water which is entering onto the particular soils, and the total soil will be water free structures. Next one is the vacuum consolidation. That means consolidation means some kind of adjustment with respect to voids, so that this vacuum consolidation will use a huge amount of tight structures without any voids or water. Next one is high vacuum densification method. That means high vacuum densification method. Normally these vacuum cleaners are used in our houses to clean the particular surface area without any impurities lying on the structure. Likely these high vacuum densification methods are used in the particular fields to de-voiding. That means de-voiding means normally what are the voids present in a particular structure, those can be de-voided by using these densification methods like vacuum densification and vacuum consolidation techniques. What is the preloading? Preloading means increase the whatever the weight the soil will have to bear after the construction. Those kinds of weights will have to be applied in the pre-condition. That means మనం ఒక స్ట్రక్చర్ని ఒక ప్లేస్లో కన్స్ట్రక్ట్ చేయడం వల్ల మనకి ఆ స్ట్రక్చర్ అనేది ఎంతైతే లోడ్ని బేర్ చేయాలో ఆ లోడ్ని మొత్తం కూడా మనం స్ట్రక్చర్ కట్టకుండానే ఆ యొక్క పర్టికులర్ ప్లేస్లో మనం అప్లై చేస్తూ ఉన్నాం. దానివల్ల ఏమవుతుందంటే మనకి ఆ యొక్క స్ట్రక్చర్ లోడ్ మొత్తం కూడా ముందుగానే సాయిల్ మీద ఎగ్జిబిట్ అయ్యి ఆ సాయిల్ ఉన్నటువంటి వాటర్ కానివ్వండి వాయిడ్స్ కానివ్వండి మనకి సెటిల్ అయిపోతూ ఉంటాయి. దస్ కైండ్ ఆఫ్ టెక్నిక్ ఈజ్ కాల్డ్ యాజ్ ద ప్రీ లోడింగ్ టెక్నిక్. Due to this preloading technique, what are the features we will obtain is it increases the bearing capacity of the soil. That means there will be a huge amount of friction between the soil particles and the foundation, so that the settlements will have a less content. There will be a less cut. That means the fractions will be takes place. Sometimes it will be no occurring of settlements also. Second one we are having is the reduces the compressibility of weak ground by achieving a pleasant temporary surcharge on the ground. That means reduces. That means reduce means a decrement of compressibility of weak ground. Compressibility means a force which is applying on a particular two directions. That I will show with some example. It is a particular pace. It is a compressive force. Whether it is a tensile force. Okay, it is the major difference between compressive force and tensile force. If the two forces are coming at a particular center, that is called compressive force. If the two forces are leaving away from the center, that is called tensile force. That is the basic difference between the compressive and tensile forces. while applying these preloading techniques, we need to avoid these pre-compressive techniques, achieving surcharge on the ground. And in cohesionless soils and gravel, we have to apply this lowering of water table, and most effective. Next, soft cohesive ground will have to obtain. Lowering water table most effective. That means water table will be lowered at a particular points due to this application of preloading techniques. But in case of soft cohesive soils, also these preloading techniques are mostly employable.